The moment Frank Whittle walked into the Air Ministry building on a gray February afternoon in 1930, he believed he held the future of aviation in his hands. He was just 23 years old, a flight officer with a radical idea, an idea so revolutionary that it would fundamentally transform every aircraft that had ever taken to the skies. But the institution that controlled Britain's military aviation did not see it that way. They saw a young man with an impractical dream, someone wasting their time with a notion that violated the established laws of engine design. What Whittle possessed was a complete blueprint for something the world had never seen before. A jet engine. Not a modification of existing piston engines, not an incremental improvement on German or American designs, but an entirely new principle of propulsion, a machine that would extract energy from burning fuel and expel the resulting gases at tremendous velocity to create thrust. Theoretically sound, mathematically elegant, and utterly impossible to construct with existing materials and manufacturing techniques. Or so the Air Ministry believed. For the next decade, Whittle would fight against institutional inertia, budget constraints, and the simple disbelief of powerful men who could not imagine that a young engineer's calculations could be correct. His engine would remain secret, not because of enemy threats, but because the British government wanted to suppress it. The discovery that changed everything would be hidden away in classified vaults and forgotten by history. It would not emerge into public knowledge until the year 2001. 70 years after Whittle first conceived it. And only then would Britain finally acknowledge what one man had accomplished in complete obscurity. To understand why Frank Whittle's jet engine remained secret for so long, you must first grasp what made it so profoundly impossible. The reciprocating piston engine had reached the peak of its evolution by the 1930s. Every aircraft designer understood its limitations intimately. The faster an aircraft flew, the less efficient the piston engine became. At high altitudes, where the air grew thin, piston engines struggled to generate enough oxygen for combustion. The propeller, that whirling disc at the front of every aircraft, became increasingly useless as speeds approached 500 miles per hour. At those velocities, the propeller tips were actually moving faster than sound. The airflow separated from the blade surfaces. Efficiency collapsed catastrophically. You could not simply build a bigger engine or a more powerful one. The laws of physics created a ceiling. Piston-powered aircraft seemed destined to max out around 450 miles per hour. Higher speeds demanded an entirely different approach. Some aeronautical engineers had theorized about turbine engines, machines that extracted energy from hot gases by forcing them through spinning turbines. But applying the principle to aircraft engines presented seemingly insurmountable obstacles. Turbines required materials that could withstand temperatures approaching 1,000 degrees Celsius without melting or losing structural integrity. Metals that could tolerate such heat did not yet exist in industrial quantities. The precision required to manufacture turbine blades was beyond the capabilities of existing machine tools. The tolerances were measured in fractions of millimeters. The weight had to be kept impossibly low. Any blade that was slightly out of balance would vibrate itself to pieces in microseconds. Whittle understood all of this. He had studied thermodynamics at Cambridge. He had absorbed the theoretical literature. He had wrestled with the equations that governed how hot gases behaved at high pressures and temperatures. And despite all the seemingly insurmountable difficulties, he believed it could be done. He believed it was not just possible, but inevitable. The future of aviation would belong to whoever mastered jet propulsion. Frank Whittle was born in 1907 in the industrial city of Coventry, at the heart of England's manufacturing heartland. From childhood, he was obsessed with flight. He built model aircraft from scrap materials. He studied aeronautics with the single-minded focus of someone who could envision nothing else for his future. At the age of 16, he joined the Royal Air Force. By his early 20s, he had published technical papers describing principles of jet propulsion. In 1930, Whittle filed a patent for his jet engine design. He was still in his early 20s, still a junior officer in the Air Force. The patent application went to the Air Ministry for evaluation. Senior engineers reviewed the concept and delivered their verdict. Interesting from a theoretical standpoint. completely impractical from an engineering standpoint. These objections were not entirely wrong. They reflected genuine technical challenges. But they also reflected something else: institutional resistance to radical innovation. The established aircraft engine manufacturers had invested enormous resources in perfecting piston engines. Why would the Air Ministry invest in developing an entirely new engine type when existing manufacturers were already delivering engines of increasing power and reliability? Whittle persisted despite the rejection. He filed amended patents in 1932 and 1934. Each time, the Air Ministry deflected the proposals. For 5 years, Whittle worked on his jet engine in isolation. He conducted theoretical calculations. He designed every component down to minute detail. He produced drawings of extraordinary complexity. But without funding, he could not build a prototype. He could only calculate, theorize, and wait for circumstances to change. It was the kind of isolation that would break most people. But Whittle was not most people. He was a man driven by an internal imperative. He was certain that he was addressing the most important technical problem in aviation. And he was absolutely determined to see it realized, regardless of the opposition and obstacles. In 1936, circumstances finally shifted. A small engineering company called Power Jets Limited was founded specifically to develop Whittle's jet engine concept. Whittle became chief engineer. After years of working in isolation, he finally possessed the resources to transform theory into hardware. The first experimental engine, designated the WU, began construction in 1937. Building that prototype revealed the true depth of the technical challenges. Every material choice involved compromise. The turbine blades were manufactured from solid steel ingots, then machined by hand because no automated process existed that could produce the required precision. Each blade had to be balanced individually to within a fraction of a gram. The compressor assembly required multiple stages. Air entered the front at atmospheric pressure. A series of spinning impellers accelerated that air progressively, compressing it until it reached pressures of approximately 4 atmospheres. This compressed, heated air then flowed into the combustion chamber, where it mixed with atomized fuel and ignited. The resulting hot gases, at temperatures exceeding 800 degrees Celsius, flowed backward through a turbine. The turbine extracted energy from those gases, using it to drive the compressor blades. Whatever energy remained in the exhaust gases flowed out the back of the engine at high velocity, creating thrust. For 18 months, Whittle and his team worked on the experimental engine. In April 1937, the WU engine was mounted on a test stand. The moment of truth had arrived. Technicians started the engine. It roared to life with a sound unlike any aircraft engine ever heard. For less than a minute, it ran, until the bearings overheated and seized. But those few seconds proved that the theory was correct. A jet engine could operate. Over the following years, improved versions were built. The W1, the W2X, the W2Y500. Each one more powerful. Each one more reliable. The technological secrets these engines contained became some of the most closely guarded in the entire British military establishment. By 1941, Britain was fighting for its survival against Nazi Germany. But British military strategists understood that the advantage piston engines provided could not last forever. Eventually, German engineers would improve their aircraft performance. At that point, whoever possessed a jet engine would control the skies. A jet-powered fighter could outrun, outclimb, and outmaneuver any piston-powered aircraft. The Air Ministry finally recognized what Whittle had been arguing for over a decade. His jet engine was not a theoretical curiosity, it was the future of air combat. In May 1941, the decision was made to accelerate development of jet aircraft. The W1 engine was installed in an experimental aircraft designated the Gloucester E-28. On May 15, 1941, that aircraft made its first flight. The pilot was squadron leader Jerry Sayer. For 12 minutes, the aircraft remained in the air, but those 15 minutes changed aviation forever. News of the successful flight was reported immediately to the Air Ministry. The reaction was immediate and absolute. Complete secrecy. Photographs were seized, Reports were classified. Test data was locked in vaults. Personnel involved in the project were ordered to absolute silence. The existence of the jet-powered aircraft and the engine that powered it were classified at the highest levels of government. The secrecy was more intense than anything surrounding radar or code breaking. The operational advantage seemed so overwhelming that British military leaders decided they could not risk any information leaking to enemy intelligence services. If Germany learned that Britain had developed a jet engine, German scientists would redouble their efforts. The decision was made to suppress all information about Whittle's engine for the duration of the war. Throughout the remainder of the war, jet engine development proceeded in hidden facilities. Whittle's health began to deteriorate from the stress of the secret work. By 1945, exhausted and frustrated, he was offered retirement. He accepted. The man who had invented the jet engine left his creation behind, knowing he could never publicly acknowledge what he had accomplished. The Second World War ended in 1945. The Gloucester Meteor fighter entered service with the Royal Air Force, powered by Rolls-Royce Derwent engines derived from Whittle's foundational design. British jet aircraft were evaluated by American and Soviet intelligence services. The technology was partially declassified, but the full extent of Whittle's achievement and the years of struggle he had endured remained classified. The official narrative became carefully sanitized. Credit was distributed among many engineers and scientists. Whittle's central role was minimized. He was described as one contributor among many. The suppression was not malicious. It was institutional. It was self-protective. Acknowledging the full extent of Whittle's achievement would require explaining why the Air Ministry had rejected his ideas for so many years. It would require admitting that senior officers had been wrong. Silence was preferable. After the war, Whittle was offered a position as an air commodore in the RAF. He served in various capacities, increasingly frustrated by continued secrecy around his own invention. In 1948, exhausted by the restrictions placed on his life and work, he left the Air Force entirely. For decades, Whittle remained largely unknown outside narrow specialist circles. The general public had no idea that the jet age they were entering had been envisioned and initiated by one brilliant but unrecognized engineer. By the 1950s and 1960s, jet aircraft were transforming aviation globally. Supersonic fighters were being designed. The Concorde was being developed. Commercial jets were revolutionizing long-distance travel. All of this was built upon the fundamental principles that Whittle had worked out 40 years earlier. Yet his name remained largely unknown outside aviation circles. The secrecy persisted long after the operational reasons for it had vanished. It was maintained through institutional momentum, through bureaucratic inertia, through the simple fact that no one with authority saw any benefit in revealing what had been hidden so carefully for so long. The years accumulated. A man's lifetime achievement disappeared into classified vaults. In 1976, Whittle was finally knighted for his contributions to aviation. He became Sir Frank Whittle. The honor came late in his life. He was in his late 60s. Recognition that should have come decades earlier now appeared almost as an afterthought. Not until 2001, nearly 30 years after Frank Whittle's death in 1996, was the full extent of the secrecy finally revealed. Declassified documents showed the entire history. The decades of effort, the institutional resistance, the wartime suppression, the post-war continued classification of information that posed no security threat whatsoever. The world finally learned what Whittle had accomplished. What had been hidden for 70 years was finally exposed. But even that revelation changed nothing for the man himself. He had already passed away. He had already lived out his final years in relative obscurity. He never received the public recognition that his extraordinary achievement deserved. The declassification revealed documents that proved Whittle had been absolutely correct in everything he had proposed. Every calculation he had made was sound. Every objection raised by senior officials had been based on conservative assumptions that later proved incorrect. The technology was possible. More than possible, it was inevitable. Someone would have developed the jet engine, but Whittle solved it first. He solved it while the world was still trapped in piston engine technology. He solved it while his own government refused to support his work. He solved it through sheer persistence and intellectual brilliance in the face of institutional indifference. Frank Whittle's story represents more than aviation history. It is a lesson about the dangers of institutional secrecy and bureaucratic inertia. The technology that transformed aviation was not suppressed by enemy action. It was not suppressed by foreign competition. It was suppressed by the very institution responsible for developing it. The jet engine changed warfare forever. It changed civilian transportation. It changed the fundamental nature of human mobility. And it was invented in isolation, in obscurity, by a man whose own government refused to acknowledge his success until long after it mattered to him. Governments have legitimate reasons to keep military technology secret, but secrecy often extends far beyond its legitimate bounds. It becomes habitual. It becomes self-perpetuating. Information that posed no security threat decades earlier continues to be classified simply because no one has authorized its release. The reputations of individuals become sacrificed to institutional pride, and the lessons that could be learned from past mistakes are buried away where they cannot inform future decisions. Britain kept Frank Whittle's jet engine secret for far longer than operational security required. When the revelation finally came in 2001, it was too late for the man himself. He could not see the vindication. He could not receive the public recognition that should have been his. The cost of this extended secrecy was paid by one man, a man whose extraordinary achievement was recognized only belatedly after he could no longer enjoy the acknowledgement. The jet engine transformed aviation and defined the modern world. It made supersonic flight possible. It enabled rapid intercontinental travel. It changed the nature of air warfare, and it was invented by Frank Whittle in obscurity, while his own government worked actively to suppress recognition of his achievement. That is the story that was kept secret for 70 years. A story not about national security or military advantage, but about institutional pride and bureaucratic inertia and the reluctance of powerful men to admit they had been wrong. Frank Whittle's jet engine remains in use today. More than 80 years after that first successful test in 1937, the fundamental principles he established continue to power modern aircraft. Every commercial jet carrying hundreds of passengers across oceans at near the speed of sound operates on Whittle's foundational concepts. Every military fighter aircraft soaring above battlefields carries an engine that traces its origins to his mathematical calculations and engineering vision. The compressor systems, the combustion chambers, the turbine designs that he conceived have been refined and improved, but the basic principles remain unchanged. This enduring relevance is remarkable testimony to the brilliance of his initial conception. It was not a design that required only minor improvements. It was a fundamentally correct approach to the problem of flight propulsion that withstood the test of time and technological advancement. The secrecy that surrounded Whittle's work for so many decades has finally been lifted. The full story is available to historians and engineers. The documents that were classified are now accessible. The recognition that was denied during his lifetime has been posthumously granted. But that recognition comes with a bitter-sweet quality. It vindicates his memory, but it cannot restore his life. It acknowledges his achievement, but it cannot give him the satisfaction of public recognition when he could still enjoy it. He died in 1996 at the age of 89, having lived a long life, but never receiving the public recognition he deserved during his most productive years. When Whittle walked into the Air Ministry building in 1930, he expected his ideas would be heard. He expected that if his calculations were correct, the institution would recognize this and provide support. He expected that truth would prevail. But it did not. Not immediately. Not during his productive years. Not until long after he had retired. His expectations were reasonable, but they were disappointed by institutional reality. Yet he persisted. He worked in obscurity for years. He developed his ideas without institutional support. He proved them right through the sheer force of his intellect and determination. And eventually, his work was vindicated. The technology was proven. The engine was built. aviation was transformed. And long after his death, his contribution was finally acknowledged. That vindication, though incomplete and delayed, serves as a lesson about human persistence and institutional failure. It teaches us that brilliant individuals can overcome institutional resistance through determination. But it also teaches us that institutions will protect themselves over acknowledging truth if given the opportunity. The cost of institutional pride and bureaucratic inertia is measured in human terms, in the life of a man who changed the course of history and never received acknowledgement for that change during his lifetime, in the opportunities lost, in the public understanding that never developed, in the lessons that were never learned at the moment they should have been learned. Every year of secrecy was a year lost. Every decade of suppression was a decade stolen from a man who should have been celebrated as the father of the jet age. The vindication in 2001 was too late. The secret that Britain kept for 70 years represents not just institutional failure, but human tragedy. And it stands as a warning about what happens when institutions prioritize self-protection over truth and bureaucratic inertia over acknowledgement of achievement. In 1930, a 23-year-old flight officer entered a government building with equations and drawings that would transform the world. He carried calculations that were mathematically sound. He had identified a problem that nobody else seemed to recognize as urgent. The future of aviation, he argued, belonged not to the refinement of piston engines, but to an entirely new principle of propulsion. The institution listened politely and rejected him. That rejection set the tone for the next 15 years of his life. While he worked in obscurity, developing his ideas without institutional support, the world changed. A war came. Nations rose and fell. Technologies that seemed impossible became real. And through it all, Whittle persisted. He worked on his jet engine while others doubted. He refined his designs while the Air Ministry questioned whether they were practical. He proved his calculations correct through sheer determination and intellectual brilliance. When his engine finally flew, it changed everything. But even that triumph could not overcome the institutional resistance to acknowledging his achievement. The secrecy that began as a matter of wartime security became a habit that persisted for decades. The man who invented the jet engine remained unknown to the public. His contribution was minimized. His struggle was suppressed. And when recognition finally came, it came too late for him to fully enjoy it. That is the human cost of institutional behavior. That is what happens when institutions prioritize their own reputation over truth. That is what occurs when bureaucratic inertia prevents acknowledgement of achievement. The story of Frank Whittle reminds us that progress often comes from brilliant individuals working against institutional resistance. It reminds us that institutions will protect themselves even when that protection comes at the cost of historical truth. And it teaches us that recognition delayed can never fully compensate for recognition denied. The jet engine is Whittle's legacy. That technology continues to power aviation worldwide. It has become so fundamental to modern transportation that we scarcely think about the genius required to conceive it and develop it in the face of institutional skepticism. Every flight in a commercial jet aircraft is, in some sense, testimony to Whittle's achievement and to the cost of the secrecy that surrounded it for 70 years. The vindication came eventually, but it came too late for the man himself. He had already spent his most productive years fighting for recognition that would not come during his lifetime. He had already watched as others received credit for developments that built on his foundation. He had already experienced the frustration of knowing that his greatest achievement would remain publicly unacknowledged for decades. When death came in 1996, it ended a life that had been extraordinary in its achievements but ordinary in its recognition. A life that should have been celebrated became instead a life of quiet obscurity. And it was not until 5 years after his death that the world finally learned the full extent of what he had accomplished. By then, there was no opportunity for him to enjoy that belated recognition. No opportunity for him to see his name finally linked with the revolutionary technology he had invented. No opportunity for him to receive the public acclaim that should have been his. Instead, his vindication came as a historical footnote. A story told by historians and engineers to illustrate the dangers of institutional suppression and bureaucratic inertia. It is a story that deserves to be told more widely. It deserves to be remembered not just by specialists, but by the general public. It deserves to be understood as a cautionary tale about what happens when institutions protect themselves over acknowledging truth. And it deserves to be recognized as a reminder that brilliant achievements can be suppressed by institutional machinery, even in nations that pride themselves on freedom and the recognition of individual genius. The secret that Britain kept for 70 years was ultimately not about military security or technological advantage. It was about institutional pride and the reluctance of powerful men to admit they had been wrong. And that secret cost one man the recognition he had earned through decades of perseverance and intellectual brilliance in the face of institutional opposition. The world that Whittle created through his invention continues to exist around us. The jet engines that power the aircraft we fly on a regular basis operate on the principles he established more than 80 years ago. The technology has been refined and improved beyond what even he could have imagined, but the fundamental concepts remain unchanged. Every time a commercial aircraft takes off, carrying hundreds of passengers across continents, that moment represents the vindication of Whittle's vision. It represents the proof that his calculations were correct, that his persistence was justified, and that his achievement deserves to be remembered and celebrated. Yet, how many passengers on those aircraft know the name Frank Whittle? How many understand that the engine carrying them across the globe was invented by a young engineer working in obscurity against institutional opposition? The answer is probably very few. The story has become buried in technical history. It has been absorbed into accounts of aviation development that mention his name but fail to capture the magnitude of his struggle. The institutional suppression that lasted 70 years has given way not to recognition but to obscurity of a different kind. The technology is known, the impact is recognized, but the man and the cost of the secrecy that surrounded him remain largely unknown to the general public. Perhaps that is fitting in some ways. Great technological achievements sometimes outlive the reputation of those who created them. The invention becomes more important than the inventor. The technology becomes more significant than the struggle that brought it into being. But in Whittle's case, understanding the technology requires understanding the struggle. Understanding the jet engine requires understanding the institutional forces that resisted its development. Understanding the importance of his achievement requires understanding the cost of the secrecy that suppressed recognition of that achievement. The technological miracle of the jet engine is inseparable from the human tragedy of a man whose contribution was denied public acknowledgement for the entirety of his productive life. That is why the story must be told. That is why the 70 years of secrecy must be remembered and understood. Not as a historical curiosity, but as a profound lesson about what happens when institutions prioritize their own reputation over the acknowledgement of individual achievement. The future of innovation depends on creating environments where brilliant ideas are recognized and supported, where institutional machinery does not resist revolutionary thinking, but instead encourages it. The case of Frank Whittle stands as a warning about what happens when institutions fail to create such environments. It is a warning that remains relevant today, when bureaucratic inertia and institutional self-protection continue to suppress achievement and delay recognition of innovation. The secret that Britain kept for 70 years is finally revealed. But revelation does not undo the damage. It does not restore to Whittle the recognition he should have received. It does not give back to him the years of struggle and obscurity. It serves instead as a testament to both human achievement and institutional failure. It demonstrates that one brilliant mind working with determination and perseverance can overcome institutional resistance and create something that transforms the world. But it also demonstrates that recognition of such achievement can be delayed, suppressed, and nearly eliminated by the operation of institutional machinery. That is the final lesson of Frank Whittle and the secret engine that Britain kept hidden for 70 years. The engineering principles that Whittle established are still studied in universities around the world. Students in aeronautical engineering programs learn about his contributions to the field. They study the thermodynamic principles that governed his design. They analyze his solutions to problems that had seemed insurmountable. And yet, most of those students probably know little about the man himself. They know that he invented the jet engine. They know the general principles of his design. But they do not know the story of his decade of isolation. They do not know about the institutional resistance he faced. They do not know about the suppression of his achievement for 70 years. In this way, the technological legacy has been separated from the human story. The invention has been absorbed into the progress of aviation history, while the inventor remains largely unknown. This separation is perhaps inevitable in the way that history is taught and remembered. But it represents a loss, because understanding the technological achievement requires understanding the human struggle that produced it. Because recognizing the genius of the design requires understanding the intelligence and perseverance that brought it into being, despite overwhelming opposition. Because appreciating the impact on the world requires understanding the cost paid by the man who made that impact possible. Frank Whittle's life demonstrates something fundamental about human progress. It demonstrates that technological advancement often comes from individuals who work against the grain of institutional thinking. It demonstrates that brilliant ideas are frequently resisted by the very institutions that should support them. It demonstrates that recognition of achievement can be delayed decades beyond when it should be granted. And it demonstrates that when recognition finally comes, it can never fully compensate for the years of suppression that preceded it. The story of Frank Whittle and the secret engine that Britain kept hidden for 70 years is ultimately a story about power and knowledge. It is about who controls information and for how long. It is about institutional interests prevailing over historical truth. It is about a man whose achievement was so significant that it transformed the world, yet whose contribution was denied public acknowledgement for the entirety of his productive life. That contradiction sits at the heart of his story. The magnitude of his achievement stands in sharp contrast to the obscurity in which he was forced to work. The world-changing importance of the jet engine stands in opposition to the suppression of the man's name and role in creating it. This contradiction tells us something important about how institutions function. It tells us that powerful organizations will protect themselves even at the cost of historical truth. It tells us that individual achievement will be suppressed if acknowledging that achievement requires admitting past errors. It tells us that bureaucratic inertia, once established, is extraordinarily difficult to overcome. These are lessons that remain relevant today, as relevant in the 21st century as they were in the 20th. The patterns of institutional behavior that led Britain to suppress recognition of Whittle's achievement continue to operate in governments and organizations around the world. The impulse to classify information not because it poses a security threat, but because acknowledging it would be embarrassing, continues to be powerful. The resistance to revolutionary ideas that threaten established power structures and commercial interests continues to be fierce. The story of Frank Whittle is not simply a historical footnote about the invention of the jet engine. It is a warning about institutional behavior and a reminder of the human cost of institutional suppression. It is a call to create systems where brilliant ideas are recognized and supported rather than resisted and suppressed. And it is a testament to the power of individual persistence and determination to overcome institutional opposition and create something that transforms the world, even if that transformation is achieved in obscurity and denied recognition for decades beyond when it should have been granted. In the end, Frank Whittle's story is not primarily about technology. It is not primarily about engineering or innovation or aviation advancement, although all of those elements are present. His story is fundamentally about what happens when individuals confront institutions. It is about the extraordinary difficulty of challenging established ways of thinking. It is about the power of institutions to suppress achievement and deny recognition. And it is about the capacity of determined individuals to overcome that suppression and create something that transforms the world, even if that transformation is achieved in obscurity. When Whittle first filed his patent in 1930, he had no way of knowing that his achievement would be suppressed for 70 years. He could not have imagined that the jet engine he envisioned would eventually power aviation worldwide, While his name remained largely unknown to the public, he could not have anticipated the institutional machinery that would work to minimize his contribution and delay recognition of his achievement. But he persisted. He worked in isolation. He refined his designs through countless iterations. He proved his calculations correct. And when the opportunity finally came to build a functioning prototype, he took it. The first successful test in 1937 vindicated everything he had believed. The engine that seemed impossible became real. The technology that institutions said could not be developed in any reasonable time frame had been created. And yet, recognition eluded him. The very institutions that had rejected his ideas for so long now appropriated his invention and claimed credit for its development. The military classified his contribution. The government suppressed the information. The public remained ignorant of his role. For 4 decades, he lived with the knowledge that his greatest achievement was being attributed to others or remaining unattributed altogether. That burden must have been extraordinarily heavy, to have changed the course of aviation and remain unknown, to have proven correct when powerful institutions had declared him wrong, to have succeeded despite overwhelming odds and continued suppression, and then to reach the end of his life without receiving the public recognition that was his due. When the declassification finally came in 2001, Whittle had been dead for 5 years. He never saw the vindication. He never experienced the satisfaction of seeing his name finally linked with the jet engine that he had invented. He never received the public acknowledgement that should have come much earlier. His death meant that the belated recognition could never fully compensate for the decades of suppression that had preceded it. And so his story stands as a final indictment of institutional behavior. It stands as evidence of what institutions will do to protect themselves. It stands as testament to the human cost of that self-protection. The secret that Britain kept for 70 years represents not a triumph of security or a victory for national interest. It represents instead a failure of institutional character, a failure to acknowledge truth, a failure to recognize achievement, a failure to honor the contributions of those who have changed the course of history. That failure cost Frank Whittle the recognition he deserved. And it is a lesson that should be remembered by every institution and every individual who encounters brilliance and innovation that challenges the established order. Recognition delayed is recognition denied, and some debts, once incurred, can never be fully repaid.